record. So our curve has to be differentiable. F of x must be differentiable in the first place, which means it has to be smooth and continuous. And then the derivative of the function has to be continuous. So then we take our curve and we cut it up into however many partitions that we need. In this case, I have 5 partitions, but I'd have n partitions. In other words, I'd cut it at x1, x2, x3, all the way up to xn. In this case, we did x of 5. And so if I look at just a piece of this, if I look at, say, from x0 to x1, then I know the change in x, so that delta x is going to be x1 minus x0. The change in y is going to be f of x1 minus f of x0. And then the distance is just the distance formula, in which I have x1 minus x0 squared plus my y's, the difference in my y squared. So in other words, the delta squared. So delta x squared, delta y squared. And then if I factor out a delta x there, then when I factor that out and then take the square root of that, I end up with delta x times the square root of 1 minus delta x, or delta y delta x, the quantity squared. But we know that delta x delta y is just f prime of x. And so my arc length is going to be the summation of I equals 1 to n of 1 plus the derivative of the function squared times delta x. If we take the Riemann sum of that and let n go to infinity, then basically what we have is we have the arc length is going to be equal to, from a to b, the square root of 1 plus the derivative squared dx. And that gives us our first theorem right there. So I'm going to stop and ask what kind of questions you have for me, or at least to catch up and write that theorem down. So when we're asked to find the arc length, because we are needing to find f prime, the first thing we're going to do is find f prime. Because after we find f prime, we actually square it. So it's important that when we look at this, if we're asked to find the arc length, is that we have to find the derivative of the function that we are looking at. So if we want it with respect to the y-axis, then we get this other formula. So here's my other formula, which in this case, my c to d are my y values, and notice that this is now in respect to y. Either way, what we want to do is we want to first find the derivative of the function, and then it'll be 1 plus that derivative squared dx from whatever our a to b is. So if I'm asked to find the arc length of this curve, which is 1/3 x squared plus 2 raised to the 3/2, and it's given me x's, so x equals 0, x equals 1, so I know it's going to be with respect to the x, because it's given me here, it's telling me I'm going from x equals 0 to x equals 1. Now, if I take a look at this one down here, for this one, they're giving me get rid of that. They're giving me this from y equals 0 to y equals 1. So on this case, I know I'm going to do it with respect to y. This one I'm going to do it with respect to x. So either with respect to x or respect to y. So let's go back up here, and the first thing we want to do is find the derivative. Which one of these would you like me to do? Would you like me to do A, or would you like me to do B? Put in the chat window which one you want me to do, A or B. A or B. Or we all just stare at each other for a while. Oh, I don't know. Wait. There we go. Now we all just stare at each other for a while. I don't know why my video wasn't showing. We can just stare back and forth. Which one would you like me to do, A or B? Because you're going to do the other one. Okay, B. So the first thing I want to do is find my derivative. So y prime is equal to, I'm going to rewrite y as equal to x cubed over 3. That's not a big deal. But I'm going to rewrite 4x raised to the negative 1, so that when I do my derivative, I remember to pull that negative down and then do the square root. So my y prime then is going to be 3x squared over 3, and then it's going to be minus it's going to be 4x raised to the negative 2 multiplied by 4. It's the chain rule. And then, so this is going to give me x squared minus 4 over 4x, the quantity squared. So that's what that's going to be. Now, what I'm going to do is I'm going to make this a single fraction because I'm going to have to do the integration. I'm going to have to square this lovely. So I'm just going to rewrite this as 16x squared, 16x to the 4th minus 4 all over 16x squared. And what I did there is I know that this is going to be 16x squared, so I multiplied this by 16x squared, the numerator and the denominator. So that's why it's 16x to the 4th minus 4 over 16x squared. Okay? So then what I'm asked to do is I'm asked to find the arc length, and so I'm going to integrate this from 1 to 3, and it is the square root of 1 plus this derivative, which is 16x to the 4th minus 4 divided by 16x squared, and that should be squared dx. What kind of questions do you have for me so far? Let's stop and ask, what kind of questions do you have for me? Okay, if there's no questions, then we're going to continue on. And so this is going to equal to the integral from 1 to 3. And what I'm going to do is I'm going to here go ahead and make this the same common denominator. And to do that, I'm going to rewrite this as the square root of 1 plus, I'll write this as 16x to the 4th minus 4 squared over, and then I'm going to go ahead and square the 16, and I'm going to square x squared. So I'm going to take the squared part first, and so I end up with my calculator out and do 16 squared. So 16 squared is 256x to the 4th. Now, mostly at this point, it's just the algebra that I need to do. So then dx. So this is going to be equal to the integral from 1 to 3. Now, it's really terrible. I can't really see that. Let me see if I can clean this up a little bit in here. So that's going to be 16x to the 4th minus 4, the quantity squared there. That's a little bit better. So I'm going to factor this out so that what I'm going to do is I'm going to take and make this over the same common denominator. And so I have the square root of 256x to the 4th plus 16x to the 4th minus 4, the quantity squared, all over 256x to the 4th dx. Now I'm going to go ahead and pull out that 256x to the 4th. So this is going to be equal to, from the integral from 1 to 3 of the square root of 256x to the 4th plus 16x to the 4th minus 4 squared, all over 16x squared dx. All right, how are we doing? Let me put this. So the first thing you have to do is you have to find y prime. Once you find y prime, then it'll be the integral from 0 to 1 of 1 plus y prime squared dy or dx. So go ahead and do A. See how far you get. The derivative on A, you're going to have to use the chain rule. It's going to be 1/3 multiplied by the power, which is 3 over 2, x squared plus 2. I'm going to drop a power, so that makes it to the 1/2. And then you're going to multiply by the derivative of the inside function, which gives you 2x. Derivative of x squared is 2x. The 3's are going to cancel, and the 2's are going to cancel, and you end up with, when you get done with the derivative, you're just going to end up with x squared plus 2 raised to the 1/2, which for this is going to be not as interesting as the one down below. So let's go ahead and set up the integration for this. Erase this so I can give myself some space. And so I'm going to integrate between 0 and 1 of the square root of 1 plus x squared plus 2 raised to the 1/2 squared dx. So the integral from 0 to 1 of the square root of 1 plus, and then I'm going to distribute the squared here and then also onto here. So it's going to be x squared, and then it's going to be the x squared plus 2, because when you take the square root of the, when you do the squared of a, when you square a square root, you get what's underneath it, and then dx. So then this is going to be the integral from 0 to 1 of the square root of 1 plus x to the 4th plus 2x squared dx. How are we doing to there? How are we doing? Okay, so then this is equal to 0 to 1. I'm just going to rewrite this as x to the 4th plus 2x squared plus 1 dx. And then I look at that and I think, wait a minute, that almost looks like a perfect square trinomial. So this is equal to 0 to 1 of the square root, and this factors into x squared plus 1, the quantity squared dx. Because that factors into x squared plus 1, the quantity squared, the squared and the square root will cancel themselves out. So if the squared and the square root cancel themselves out, then I just have from 0 to 1 of x squared plus 1 dx. And then that's a pretty straightforward integration. It's going to integrate, this is going to be x to the 3rd divided by 3 plus x, evaluated from 0 to 1. So 1/3 plus 1 minus 0. So 1 1/3, or 4 over 3. And there's my final answer. What kind of questions do you have for me on that? What kind of questions do you have? Mostly was the algebra. You can unmute yourself and ask the question. My sound bar is working today. I got all my technology working. Oh, it would just be unit, because this is just length. So it'd be whatever unit it is. So if I was finding the arc length of some shape in meters, then it would have been just meters. So it's a linear unit, so it's just a unit. It's not cubed because that's volume. It's not squared, that's area. So it's just a unit. How was that? Anything else on that one? So it's more or less the algebra. Okay. So if there's no other question, let me erase all of this so I can move over. And do the next one. Okay, so if you all could do C and D, please. C and D. Now with D, we're doing with respect to Y. So on C, the first thing you always have to do is find the derivative. So that's what we did here, is we found the derivative. So we found the derivative. Once we found the derivative and we cleaned it all up, we put it into the formula, the square root of 1 plus the derivative squared dx. Now, when you square a square root, the square root part comes off. You don't forget to square that x, so that x also has to be squared. And so that's how come I got x squared. Then I went ahead and distributed the x squared through, because I'm hoping things will clean up algebraically. So then when I distributed it, I ended up with 1 plus 9x to the fourth plus 6x squared. I reordered it with the highest power first. And then I realized that this is a perfect square trinomial that factors. And I can't flog enough how important knowing the perfect square trinomial is. Factoring is so important. And this is what it factors into. And then when you have a square root of something squared, whatever underneath the radican comes out. And normally we should put in the absolute value if we're not certain, but this is definitely going to be a positive number regardless, because of the fact that the x is squared there. So no matter what we put in, it's going to be a positive number. So we don't have to worry about the absolute value. And then we integrate, so that means we're going to add a power to that 2 and divide by it. So it's just x cubed plus x from 0 to 2. And so I get 2 to the third plus 2 minus 0. So I end up with an answer of 10 units. How was that one? Is that okay? Do you want to go over it again? Are we feeling pretty confident on C? Okay, so let's take a look at B. We're going to do the derivative, and so we're going to have 5 multiplied by 3 halves y raised to the 1/2. Now this isn't going to clean up algebraically, so unlike my previous one where I had some algebraic cleanup, I'm not going to have any algebraic cleanup on this really to do. I can write this as 15 over 2. I probably will. So I'm just going to rewrite this as 15 over 2y to the 1/2. And then I'm going to go ahead and put that in there for integrating between 0 and 1, the integral of 1 plus 15 over 2y to the 1/2 squared dy. So this is going to be from 0 to 1 of the square root of 1 plus 225 is what I think 15 squared is. I have to check that. 225, yeah. So plus 225 over 4y dy. And then this one is going to be a pretty straightforward u substitution. So we're going to let u equal 225 over 4y. That means du is equal to 225 over 4 dy. And then I have to adjust because I don't see that 225, so it is going to be 4 over 225 du is equal to dy. And since I have changed my variable to a u, I do need to change my limits of integration. So I do need to change this 0 and I need to change this 1. So I'm going to change that when y is equal to 0. U is equal to 225 over 4. Or excuse me, it equals 0. And then when y is equal to 1, u is equal to 225 over 4. So then this is going to be equal to 0 to 225 over 4. And then I'm going to have 1 plus u. Don't forget I have to have my adjustment. I need 4 over 25, so I'm just going to put that out. 4 over 225 out front. du. Now, when we do this integration, then what we have is this is equal to 4 over 225, integrated from 0 to 225 over 4. I'm going to write this as 1 plus u raised to the 1/2 du. And if we think about what we can do another u substitution here. That's totally fine. Let's call it w if you want. We can totally do that. Or you can see that when I integrate 1 plus u to the 1/2, I must have started out with 1 plus u raised to the 3/2, and that means I need to adjust for the multiplier. Or I can do u substitution again, and if I want to do u substitution, then I'm going to say let w equal 1 plus u. That means dw is equal to du. And the only reason I would do that is so that it would make this part become w to the 1/2. And then I know that when I integrate w to 1/2, this would end up being w raised to the 3 over 2 multiplied by 2/3. So doing that without a complete u substitution or a w substitution there shows me that when I do the integration of 1 plus u to the 1/2, that it will be 2/3 1 plus u raised to the 3/2. So I'm not going to do a full u substitution there. It's just going to help me see, oh, I know that what this part's going to integrate to. This part right here is going to integrate into 2/3 1 plus u raised to the 3/2. So then this is going to be equal to 4 over 225 multiplied by 2/3 1 plus u raised to the 3 over 2. Integrated between 0 and 225 over 4. How was that? How was that? Let me put this on pause. I decided that I'm going to let u equal this portion only. So that's what I let u equal. When I do the derivative of that, then I'm just going to get the 225 over 4. But in my original function up here, I don't see 225 over 4 outside of what I'm expecting u to be. So I don't see it right here as a multiplier, and I don't see it here as a multiplier. So if I decide that u is 225 over 4y, then dy would just be that constant, which is the 225 over 4. But that's missing here. So to adjust for it, I divide both sides by 4 over 225. So then when I do this replacement for dy, so this replacement here for dy has to be replaced with 4 over 225 du, because that's the replacement right here. So when I did the u substitution, I had to adjust for that 4 over 225, so that's where that came from, because it really is, it's not, this is what should be there, it's not here, so I adjust for it with my u substitution, and I put it out front. Now I could have put it here, but it's just a multiplier, so I put it out front. Does that help? Where that 4 over 220. If there's no other questions, then what I'm going to have you do is let me erase all of this. And I'm going to have you go ahead and do the next one. So I'm just going to erase this so we have the space. So if you all could do the next one. Make this a little bit larger. So the next one, and then we'll stop there because we're going to start surface area tomorrow. So first thing you want to do is find the derivative, and this time we were respecting with respect to y, which is not a big deal, but find the derivative first. All right, so let's take a look at where we are so far on this one. For e, we take the derivative of x, which is going to be 1/2. And then 1/2 is just a multiplier, so I can multiply it through if I want, or I'm going to leave it out front. It's just going to be a multiplier. So I'm going to take the derivative of e to the y, which is e to the y. I'm going to take the derivative of e to the negative y is negative e to the y. This 1/2 is just a multiplier. If you're inclined, you could have multiplied it through, and I'm not actually using the chain rule here. What I'm doing is I'm just doing the derivatives, each one of these individually, and then 1/2 is just a multiplier. And that's because the power here is 1, so I don't have to do the chain rule. It is simply doing the derivative of each one of them with 1/2 as a multiplier. So then my integral is going to be 1 plus, and then 1/2 e to the y minus e raised to the negative y squared dy. So from -1 to 1 of 1 plus, and I'm going to take the I'm going to square 1/2 so I get 1/4. Then I haven't done anything here. All I did was I've squared the 1/2 to get 1/4, and I left that squared so you can see the steps that I'm doing. Now, when I went on over here, move that out of the way. So I went over here. So I went over here is I went ahead and I multiplied out the e to the y minus e to the negative y squared. So that's going to be my first term squared, which is e to the 2y. And what I'm using is, when I have e to the y squared, this is a power to power rule, so it's e to the 2 times y. So that's why it's e to the 2y there. So then that's where I got e to the 2y. And then because it's a perfect square trinomial, it's going to be -2. And then I'm going to multiply these to e to the y, e to the negative y. And then plus my last term, which is e raised to the negative y squared. So it is negative. So it's e raised to the negative 2y. So then from here to here is I just added these two exponents. So the rule that I'm using there is if I have a to the m multiplied by a to the n, this is a to the m plus n. And in particular, when I added these two exponents, it becomes 0. So when I add the two exponents and say I get e to the 0, this is equal to 1. And so that's why it's just -2 right there. So the -2 simply comes because of these two collapse together, and I could just get -2 times 1, or just -2. And then from this step to this step is what I did was I wanted, this is all over 4, so I want to make this over 4 so that I can bring it in. And so I have the square root of 4 plus e to the 2y minus 2e to the negative 2y to the 4th. And so I'm just going to continue with the algebraic cleanup. So from -1 to 1 of the square root of e to the 2y plus 2 plus e to the negative 2y. I'm going to take the square root of 4 separately, so that's over 2 dy. All right, so believe it or not, this actually factors. It's a perfect square trinomial, and the numerator factors into, from -1 to 1, of the square root of e to the y plus e to the negative y raised to the 2, all over 2 dy. And when I square a square root, I'm going to get from -1 to 1 of e to the y plus e to the negative y divided by 2 dy. So in other words, I have 1/2 as a multiplier from -1 to 1 of e to the y plus e to the negative y dy. Oh, so the question is, when I went here from -2, why is this +2? And that's because I had this 4. I added to the -2, which gives me a +2. And that's why it ended up being a +2 there, not a -2. And that's because I had this +4 from here when I made this 1 to 4 over 4 so I can bring it into the fraction. So that's the 4, and then 4 minus 2 is a positive 2. I think that's what you're asking me as to why that's a positive 2, not a negative 2. I think that's what you're asking me. And then at this point, I just do my integration. And so it is 1/2. The integral of e to the y is just e to the y. The integral of e to the negative y is negative e to the negative y. Evaluated from -1 to 1, and then we just put those numbers in there, and then whatever shakes out, shakes out. So that's where we're going to stop for today. Tomorrow when I see you all, we're going to pick up the surface area. So we're going to finish this section tomorrow, and we may or may not start 2.5 tomorrow. So I have office hours today from 12:30 to 2. There's a link in the announcements, and I think I sent it to you as an email. You'll want to use that link. If you are set to meet with me one-on-one outside of my 12:30 to 2 office hours, then you're going to use that other link that is also there. So if you click on the office hour link, there are 2 links within the modules that you can see. One is for my regular office hour, and one is the one-on-one, and that's because my one-on-one, the room locks. My office hour, you should be able to come in and out without having to wait for me to open it for you. So office hour link has changed. It should be in your email. It's in the announcements. It's also in the modules. So if you look under modules, there's 2 links. So anyways, you all have a great morning. Maybe we'll get some sunshine. If you have questions, don't hesitate to ask. If you have questions on the quiz, come in and see me during office hour and or some other time. The quiz is due tomorrow morning at 9 a.m. in the Dropbox for the first iteration. So ideally it is complete with at least 1 mistake, but do the best you can. You want to have something there so that people can give you some feedback. Otherwise, you all have a great afternoon, and we will see you tomorrow if I don't see you later today.